Welcome to David Alexander Maths Tuition. This is chapter 7c on the double angle formulae. So here is the first double angle formula. So we know that the sine of A plus B can be written as sine A cos B plus cos A sine B. So therefore, if it's the sine of A plus A, then that can be written as sine A cos A plus cos A sine A. Now cos A sine A cos A, they're the same thing. So in fact, the second cos A sine A, I could just call that sine A cos A if I wanted to. There's no reason why the cos goes first, really. So what we've got here is one sine A cos A plus another sine A cos A. So we have two sine A cos A's. So the sine of A plus A, well, that A plus A is 2A. So this is our new formula. The sine of 2A, that can be written as 2 sine A cos A. Okay, so here's the second double angle formula. We know that the cos of A plus B can be written as cos A cos B, subtract sine A sine B. So therefore the cos of A plus A, which is the cos of 2A, that can be written as cos A cos A, take away sine A sine A. Now cos A times cos A, that's the cos of A squared, so that can be written as cos squared A, and sine A multiplied by sine A, well, that is the sine of A squared, so that can be written as sine squared A. So here we have it. The cos of 2A is cos squared A minus sine squared A. Now, it's rare that you'll be using it. Well, it's not always very useful to write the cos of 2A as cos squared A minus sine squared A. You'll probably want to write it as the second or the third option here. So how do we get there? Well, we know if we go from the cos squared A minus sine squared A, we know that cos squared A is the same as 1 minus sine squared A, because cos squared plus sine squared is 1. So if I replace the cos squared A in the cos squared minus sine squared with 1 minus sine squared, I get 1 minus the sine squared A, so that's the cos squared A part. Take away the sine squared A, so that will give me the 1 minus 2 sine squared A. Similarly, if we replace the sine squared A here with, so sine squared A is 1 minus cos squared A. So if I were to replace the sine squared A with 1 minus cos squared A, then that will become cos squared A, take away 1 minus cos squared A, and that can be written as cos squared A, take away 1 plus cos squared A. So what we have here is 2 cos squared A's minus 1. So 3 ways it can be written: cos squared minus sine squared, 1 minus 2 sine squared, or 2 cos squared minus 1. Okay, so on to the third and final double angle formula. We know that the tan of A plus B can be written as tan A plus tan B over 1 minus tan A tan B. So if we have the tan of A plus A, in other words, the tan of 2A, that can be written as tan A plus tan A all over 1 minus tan A tan A. Now, of course, tan A plus a tan A, that can be written as 2 tan A, and on the bottom we have 1 minus tan A times tan A is the tan of A squared, so that is tan squared A. So there we have it. The tan of 2A is 2 tan A over 1 minus tan squared A. Okay, so in the book there's a series of questions that are really quite fiddly. So what we have here is 2 sine 50 cos 50. So what we need to think is, right, we've got sine of an angle multiplied by the cos of the same angle. So that is to do with the double angle formula for the sine of 2A. So it might be worth just making a note that the sine of 2A is 2 sine A cos A. Okay, so what we have here, we've got the 2. So here A is the 50 degrees. So therefore, we can write this as the sine of 2A. So what we have here, this is written in the form of 2 sine A cos A, and we can write it as the sine of 2A. Well, we can see clearly that A is 50 degrees, so we can write this as the sine of 50 plus 50, which would be a fairly silly way of writing it. A much more sensible way would be to write that this is the sine of 100 degrees. Okay, now the second example, we've got this double angle formula, which is 2 cos squared A minus 1, and that is another way of, well, this is one of the ways we can write cos squared A minus sine squared A. We're just replacing the sine squared A with another 1 minus cos squared. So, and this is the double angle formula for the cos of 2a. Okay, so here a is 56 degrees, so therefore 2a will be double 56 degrees, so this can be written as the cos of 2 times 56, which is 112 degrees, which is clearly much easier than writing 2 cos squared 56 minus 1. Okay, for this second example here, we can see that this is 4 lots of 1 minus 2 cos squared 32. So 1 minus 2 cos squared, well, that is 1 minus 2 cos squared a. And remember that 1 minus 2 cos squared a, that is another way we can write cos squared a minus sine squared a, which is the same as the cos of 2a. So here the a is 32 degrees, so therefore 2a is going to be 64 degrees. So this part here can be written as the cos of 64 degrees, and it's multiplied by 4, so overall this is 4 cos 64. These questions in the book, I must say, are very fiddly, quite annoying. Generally, you're probably not going to be doing much, if any, of this in your natural A-level question. Well, I think it's quite unlikely, but it's just good to play around and just manipulate these formulae and just, well, we'll just play around with them, really. Okay, so here are a couple more examples. So hopefully on the top one, we can see that this is 2 lots of cos squared 32 take sine squared 32. And hopefully we now know that cos squared a minus sine squared a is the cos of 2a. So here a is 32. So 2a will be 64. So this is 2 cos 64. Okay, this bottom one, this is the double angle formula for tan. So hopefully we know that the tan of 2a is 2 tan a over 1 minus tan squared a. So here we can see that a is 32 degrees, so therefore 2a will be 64. So we can write all of this quite simply as the tan of 64 degrees. Okay, so here's another one, 6 cos squared 4 theta minus 6 sine squared 4 theta. So we can see straight away that that is 6 lots of cos squared 4 theta minus sine squared 4 theta. Now we know that cos squared a minus sine squared a is the cos of 2a. So this here a is 4 theta, so 2a will be 8 theta. So we can write this as 6 times the cos of 8 theta. Quite nasty, that one. Okay, so here is another one. Because it's sine times cos, then that is that's coming from the sine of 2a being the same as 2 sine a cos a. Okay, so what we've got is we've got 32 sine 8 theta cos 8 theta. Now I do find like these are quite tricky, and I do find I need to compare them to the double angle formula, but it's worth writing out sine 2a equals 2 sine a cos a. So here we can see that the a is 8 theta, so therefore our 2a is going to be 16 theta. So here we can see what happens to the 2. Well, the 2 gets halved, it becomes 1, so the 32 needs to be halved as well. Sorry, I should have written sine there as well. So the 32 needs to be halved, so this turns into 16 sine 16 theta. Okay, so this last example looks a little bit on the tricky side, but hopefully we can see that this comes from the cos squared minus sine squared. So here we know that 1 minus 2 sine squared theta, that is the same as the cos of 2 theta. Now we've got 8 minus 16 sine squared theta over 4. So the theta turns into a 2 theta. So here the theta over 4 needs to be doubled, so that is going to be theta over 2. And 1 minus 2 sine squared turns into 1 cos 2 theta. But here we've got, this is 8 times more, so that will simply turn into 8 cos half theta. So yeah, pretty nasty, some of these. Okay, here are a few more examples to finish off with. So we know that the tan of 2a is 2 tan a over 1 minus tan squared a. So here we can see that a is theta over 4. So what I've written here is the same as this example here. The only difference is that a is theta over 4. So if I double the a to get my 2a, that will be theta over 2. So this is simply the tan of half theta, or theta over 2. Okay, so the square root of 1 plus cos 4 theta. So this one is really not that obvious at all. And the reason probably why is because it says cos of 4 theta, not the cos of 2 theta. Well, we know that the cos of 2 theta, that can be written as cos squared theta take away sine squared theta. So therefore the cos of 4 theta, that can be written as cos squared 2 theta minus sine squared 2 theta. Okay, so what I have is the square root of 1 plus cos squared 2 theta minus sine squared 2 theta. Now probably what is going to make sense here is if I turn, I'm not really sure at the moment which I'm going to change, so let's just play around. I know that I can turn this into 1 minus 2 sine squared 2 theta. So the cos of 4 theta is 1 minus 2 sine squared 2 theta. So if I add the 1 to that, I get 2 minus 2 sine squared 2 theta. However, if I turn it into the 2 cos squared 2 cos squared 2 theta minus 1 and add the 1, then all I'm left with is 2 cos squared 2 theta. So this can be written as the square root of 2 cos squared 2 theta, and that can in turn be written as root 2 multiplied by the square root of cos squared 2 theta. So therefore that can be written simply as root 2 times the cos 2 theta. So that one needed quite a lot of playing around, and quite a nasty one, that one. So let me just quickly delete all the ink so I can attack the last one. Okay, so this last one's a little bit nasty. So first of all, I'm going to write it as 4 lots of sine theta cos theta squared. Sine theta cos theta all squared is sine squared theta cos squared theta. So sine theta cos theta, well, I know that the sine of 2 theta is 2 sine theta cos theta. So if I've only got 1 sine theta cos theta, that's what I've got inside the brackets, then that is going to be, well, that's half of 2 sine theta cos theta, so that's going to be half of sine 2 theta, so that's half sine 2 theta. So what I have is 4 multiplied by 1/2 sine 2 theta squared. Quite tricky, this one, as I said. So that's 4 lots of 1/2 squared multiplied by sine of 2 theta squared, or sine squared 2 theta. 1/2 multiplied by 1/2 is 1/4, and 1/4 times 4 is 1. So simply this can be written as just sine squared 2 theta. Okay, so yes, pretty horrible ones on that slide. Okay, so here's a proof style question. So show that cos A plus sine A all squared is always the same as 1 plus sine 2A. Okay, so let's just expand these brackets. So that's going to be cos squared A plus sine A cos A plus another sine A cos A. So plus 2 sine A cos A plus sine A times A, sine A times sine A, sine squared A. So cos squared A plus sine squared A, that is 1. So 1 plus 2 sine A cos A, and hopefully we remember that the sine of 2A is 2 sine A cos A, so that's 1 plus sine 2A, which is exactly the same as the right hand side. Okay, hence find the exact value cos 3 pi over 4 plus sine of 3 pi over 4 squared. Okay, so the clue's in the word hence, so we're referring back to this. Okay, so A is the 3 pi over 4. Now we know that the cos of something plus the sine of something squared is always the same as 1 plus sine of 2a. So I'm going to write this as 1 plus the sine of 2 times by 3 pi over 4. So that is going to be 3 pi over 2. Okay, so now all we need to do is grab our calculator, or just think of maybe the sine wave here. Okay, so here we have, this is sine, so 0, pi, 2 pi, pi over 2. So this here is 3 pi over 2. The sine of 3 pi over 2 is -1. So what we have is 1 plus -1. So all of this is just 0. So the exact value of the cos of 3 pi over 4 plus sine of 3 pi over 4 all squared is 0. And if you want, just type that into your calculator just to double check. We do get 0. Okay, so we want to find the exact value of cos 2x. So just thinking back to our double angle formula, we know that the cos of 2a is cos squared a minus sine squared a, or it's 1 minus 2 sine squared a, or it's 2 cos squared a minus 1, which seems the best one to use here. Of course, a is x. Okay, so the cos of 2x, that is going to be 2 times cos squared x minus 1. So 2 times the cos of x squared, take away 1. Well, we know cos x is a third. So this is going to be 2 multiplied by 1/3 squared minus 1. Well, a third multiplied by a third is a ninth. So that's going to be 2/9. Take away 1. Well, 1 is, of course, 9/9. So the exact value is -7/9. Okay, here's another example. What are the possible values, plural, of sine x when cos of 2x is 7/9? So we know that cos squared x, we can write that as cos squared x minus sine squared x. We can write it as 2 cos squared x minus 1, or 1 minus 2 sine squared x. So we want sine x. So maybe it's better to use the one that's only got sines in it. So I'm going to take this one. So cos of 2x, that can be written as 1 minus 2 sine squared x, has a value of 7/9. So 1 take away 2 sine squared x equals 7/9. So -2 sine squared x is 7/9 minus 1. So -2 sine squared x equals -2/9. So therefore positive 2x is positive 2/9. Divide through by 2. So sine squared x, let me just take my workings over here, is half of 2/9, which is 1/9. So therefore the sine of x is going to be the square root of 1/9. So we just need to be careful here. The answer isn't just 1/3, it's also -1/3. So if the sine of x is the square root of a ninth, then sine x is plus or minus 1/3. And we're done. Okay, for this question, we've been told that the sine of theta is 7/25. So if it's 7/25, I'll do a little right angled triangle. Here is my theta, so that means the opposite must be 7 and the hypotenuse must be 25. Therefore, I can work out the adjacent, which is 24. Okay, so what is, we know first of all that the tan of 2 theta, we can write that as 2 tan theta over 1 minus tan squared theta. So what is the tan of theta? Well, the tan of theta is simply 7/24. Now we need to be careful. It says theta is obtuse. So think of your cast diagram, CAST. If it's obtuse, it is between 90 and 180. So it's in this quadrant here where sine is positive. We can see sine is positive, so that means tan is negative. So the tan of theta is negative 7/24. So what we need to do is 2 times minus 7/24 all over 1 minus 7/24 all squared. So let's just deal with the top. So that's going to be minus 14/24, or minus 7/12 over, now negative 7/24 squared is the same as 7/24 squared. So 7 times 7 divided by 24 divided by 24, that is 49 over 576. And if I take that away from 1, I get 527 over 576. So you might want to write this as minus 7/12 divided by 527 over 576. In other words, minus 7 over 12 times 576 over 527. So we know the answer will be negative. So on top it's 7 times 576, and on the bottom we divide by, what do we get? On the bottom we get, so on the top as a simplified fraction it's going to be 336 over 527. Sorry, that wasn't the answer to the sine of 2 theta, that was the answer to the tan of 2 theta. So the answer is negative 336 over 527. So with these ones, yeah, draw out your little triangle, work out the missing side, and don't forget to factor in that, well, just think about, is it positive or negative? Here tan was negative because we've been told theta is obtuse, so it has to be in this quadrant. So the sine of 2 theta, that is 2 sine theta cos theta. So again, let's just bring up the triangle. So here's my theta, 7, 25, so the adjacent's 24. So 2 times the sine of theta, which is 7 over 25, multiplied by the cos of theta, which is 7, no it's not, it's 24 over 25. Now theta is obtuse, so this is the quadrant where only sine is positive, so the cos is negative, so it's minus 24/25. So what does that come to? We know it's going to be negative because there's only one negative symbol in the whole calculation here. So 2 times 7 times 24 divided by 25 divided by 25, and we get negative 336 over 625. Okay, so the cos of 2 theta, we know we can write that as cos squared theta minus sine squared theta. We can also write it as 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Well, I think given that I know what the sine of theta is, I'll go with this final option. So it's 1 minus 2 times sine squared theta. So that is going to be 7 over 25 all squared. Okay, so first of all, I'm just going to square the 7 over 25. And so that's 49 over 625. Multiply that by 2, 98 over 625, and subtract that from 1. So therefore the cos of 2 theta is 527 over 625. Okay, now for the cos of 4 theta, we need to remember that this can be written as cos squared 2 theta minus sine squared 2 theta, which can also be written as 2 cos squared 2 theta minus 1, or 1 minus 2 sine squared 2 theta. So here it's 2 theta because it was 4 theta here. Now, I know that the cos of 2 theta is 527 over 625, so I'm going to pick this one here. So the cos of 2 theta is 529 over 625. So all I need to do is 2 lots of 527 over 625 squared, and then take away 1. I'm probably going to be a fairly diabolical number here. So 527 divided by 625, square that, multiply it by 2 and subtract 1. I'm not getting an exact value here. My calculator can't cope with that. I'm getting 0.42197248. I mean, I suppose I could do this manually. In an exam, I think they would perhaps give you definitely nicer numbers than this. 527 times 527. So, oh gosh, I can see why there's a problem here. So 5555458 over 625 times 625 is 390625. Take away 1. So all I need to do is, so remember that 1 is 390,625 over 390,625. So if I simply subtract 390,625 from 555,458, then I am done. So, sorry, my workings are going all over the place here. So that is 1,64833 over 390,625 if we want the exact value. Again, a bit of a ridiculous number. Perhaps I should have thought through the question a bit better so we don't have these ridiculous looking fractions. But what I am going to do is I'm just going to divide that by 390,625. Sorry, I'm just going to turn this into a decimal just to check that I get the 0.42. And I do. So yeah, I know that that's right. But don't panic. In an exam, you get better numbers than that. That's for sure.